This is our lecture of financial management, and the topic that we are discussing is bond valuation. Specifically in this lecture we would discuss valuation of coupon bond. Let's discuss the contents. In this lecture we would understand what do we mean by valuation of a coupon bond. If you remember from the previous lecture, we discussed there that there are two types of bonds. One is called the coupon bond, and then there is a zero coupon bond, and there are different methodologies to estimate or analyze the coupon and zero coupon bond. In previous lecture we understood the method of analyzing the zero coupon bond, and in this lecture we are going to evaluate the method of valuation method of coupon bond. And then we would discuss what is effective annual rate, which we call EAR. Moving on to the next slide. So valuation of coupon bond. For coupon bond we must consider not only the coupon value, which is the interest payment, but also the terminal or the face value in valuing the bond. So if you remember from our previous formula, which was the formula of zero coupon bond, because there was no coupon, so we were finding the present value of only the face value, right? There was only one future value, and that future value was the face value. And when would we have that future value? When the bond would mature. So there was only one value. There was no interest payment. So we just needed to find the present value of this one face value. But in case of a coupon bond, we have two types of cash flows. First one is the fixed cash flow of interest payment, which we call the coupon value, and the second is the fixed payment of the face value that we would have at the maturity. This is the similar concept that we had in the case of zero coupon bond. So this is that specific formula that we have already discussed. What this formula is used for? To find the present value of face value. If you remember, we had in our time value of money, we had discussed a concept which is called annuity. What was annuity? Annuity was a fixed cash flow for a finite time period. So in case of a bond, there is a fixed interest payment, say of ₹100 or ₹50 for a fixed time period. Now if we wanted to find the present value of annuity, we discussed ordinary annuity and annuity due, but let's just not get into that. If we wanted to find the present value of annuity, we used this formula, remember? And the formula was C, which was the cash flow, into 1 minus 1 divided by 1 plus R. We used the term R raised to power n, this whole divided by R. In this case we are replacing R with YTM, but the formula is same. So we had this formula is for the zero coupon bond, and this formula is to find the present value of annuity. So what when we are finding the intrinsic value of a coupon bond, what we are doing is, theoretically we are discounting all these cash flows and finding the present value. So we need to discount the periodic cash flow that we would receive, which would be in form of annuity, and then we need to discount the face value that we would receive, the lump sum amount that we would receive at the end of the maturity. So we just need to find the present value, and that present value would be the bond value. So moving on, Suppose there is a corporation ABC company that were to issue a bond that would mature in 10 years. The bond has an annual coupon of 80. Remember, this is the fixed interest payment, periodic interest payment. In our example, this would be what? This would be C. Similar bonds have a yield to maturity of 8%. This doesn't mean anything. It just means to say that the yield to maturity of this bond is 8%. So if similar bond have the yield to maturity of 8%, then this bond also have the yield to maturity of 8%. Its face value is $1,000. What would this bond sell for? We just need to find the present value of this bond, or we need to find the true value or intrinsic value. And what would that intrinsic value be equal to? It would simply be the present value of all this C and this face value. So we need to use the formula that we discussed in previous slide to find the true value, intrinsic value of the coupon bond. So let me get you the solution. So we have this formula. This is our example 3, and we are finding the valuation of coupon bond. So bond value is equal to C into 1 minus 1 by YTM, 1 plus YTM raised to power n divided by YTM, plus the face value divided by 1 plus YTM raised to power n. In our previous example, C was 80 because these are the periodic payment. So C into 1 minus 1 divided by 1 plus the YTM. YTM was 8%. How do we know that? Remember, 8%. So this whole raised to power 10. Why 10? Because this bond was to mature in 10 years. So using this, we find that the present value of all these periodic cash flows is 536, and the present value of this face value is 463. If we add them up, we get 1,000 rupees. So the intrinsic value of this bond is 1,000 rupees. Now you would be surprised that the face value is also 1,000 rupees. Let me get back to this slide. The face value is also 1,000 rupees. How is that so? So now we have understood the calculations, but just in the side note, let me give you an idea. So this 8%, when you say that the coupon was 80 rupees, if we convert this into percentage, how much percent is this? So coupon is 8%, and YTM is how much? It is also 8%. So when YTM is equal to coupon rate, then the face value would be equal to the present value, right? I repeat, when the YTM is equal to the coupon rate, then the face value would be equal to the bond true value and intrinsic value. And there is no need to do this whole process. It is if you just got a question on this pattern where the C was 8% and the YTM was also 8%, the coupon rate was 8%, this is the coupon rate, and the YTM was also 8%, then you immediately know that neither the bond is selling at the premium nor it is selling at discount. It would be selling at its face value. Its intrinsic value would be equal to its face value. And in the end of this chapter, we would discuss the concept in detail. So let's move on to our next example. Okay, this is also an example related to valuation of a coupon bond. Let's discuss this example. A bond issued in United States usually make a coupon payment twice a year. Remember, somewhere in our discussion on time value of money, we discussed an idea of M. And what was M? It was frequency of compounding. So whether the compounding is once a year, twice a year, thrice a year, or whatever the frequency of compounding is. In this case, the frequency of compounding is twice a year. That means if you buy a bond that matures in 1 year, and let's say if the compounding was once a year, then what would that mean? This is today and this is after 1 year. So if the compounding was once a year, then you would get the interest at this point, right? Whatever the interest is, let's say it is 14%, then you would get this 140 rupees at the end of first year. But let's suppose that the compounding is twice a year. Then what would happen? This is the end of first year, but the interest would be paid after 6 months. So you would get 70 rupees after 6 months, and this would be added into your account, your balance, and then you would get 70 rupees here. But let's say that in this case of bond, this will be the scenario, right? This is today, and after 6 months you would get an interest payment, and then after 6 more months you would get an interest payment. So what is happening basically is this 140 is divided in twice a year, right? So you are getting this interest payment twice a year. So if an ordinary bond has a coupon of 17%, so coupon is 17% annually, but it is compounding semi-annually, and the yield to maturity is 16%, this is our YTM. The bond matures in 7 years, this is our N. The face value is 1000. What is the bond price? So first we discuss this idea, this question, and then we would look at the effective annual rate. Now, from our present value discussion, when we discussed the time value of money and we found the present value of an interest rate or whatever the question was, where there was semi-annual compounding, then what we did was we transformed our previous formula into a new formula. So our previous formula was this one. And how do we transform it? Wherever there is a C, we divide it by M. Wherever there is YTM, we divide it by M. So C and YTM will be divided by M, and N will be multiplied by, I do not have much space here, but let me write it here. N will be multiplied by M. So we have transformed our valuation of coupon bond formula into a new formula which we would use when there is compounding more than once a year, semi-annual or quarterly or daily or monthly compounding. So we just need to transform this formula into a new formula. So this is how it would look like. Remember, C would be divided by M. Wherever there is YTM, it would be divided by M. And wherever there is N, it would be multiplied by M. So what is M? It is frequency of compounding, we know that. But what would be the number? So if the compounding is twice a year, then M would be 2. If it is quarterly, then how many quarters do we have in a year? Yes, 4. If it is monthly compounding, then how many months do we have in a year? And you guessed it, if it is daily compounding, then how many days do we have in a year? And we can say 360, 365. There are different conventions you can use for this class. You can use 365, say for example. So M would be this number. In this specific question, the compounding is twice a year. So in this case, the M would be 2. So wherever there is an M, and we would just replace it with 2, and let's go towards the solution. This was our example. The coupon rate was 14%. Face value is 1000. Here we do not have the coupon amount, so we need to first calculate the coupon amount. So 14% multiplied by, or 0.14 multiplied by 1000, it would give us 140. This is the coupon amount, which in our example would be C. The YTM is 16%. The face value is 1000. We are using the same formula that I showed to you in our slide. C divided by M. M is 2 because it is semi-annual compounding, multiplied by 1 minus 1 by 1 plus 0.16, which is YTM. YTM is divided by M raised to power. This bond is going to expire in 7 years, so this 7 is N multiplied by M. It doesn't matter where you do it like this, 2 multiplied by 7 or 7 multiplied by 2, the answer would be the same. This whole divided by 0.6 divided by M, which is YTM divided by M, plus 1000, this 1000 divided by 1 plus YTM by 2, this whole raised to power 2 into 7. 2 is the M and 7 is N. By simplifying this formula, we get the answer 917. And what would this 917 mean? It would mean that the true value of this coupon bond is 917 rupees if this bond had this specification. So if I'm an investor, I'm going to buy this bond, I shouldn't buy it at the price higher than this price. So if market value was 1000 rupees, then market value was higher than the intrinsic value, which intrinsic value is 917, so that bond would be overvalued in the market. And if I was a corporation, I shouldn't sell this bond at less than 917 rupees. So let's move back to the slides. We have covered our first concept, which is valuation of a coupon bond. The second is the effective annual rate. And what basically effective annual rate is? The interest rate expressed as if it were compounded once a year. So in previous example, we had this YTM 16%, but it was compounded twice a year. So if we wanted to find a YTM, that would be, a YTM, an annual YTM, then we need to use this formula. We actually need to find the effective annual rate. And I repeat, what is effective annual rate? The interest rate expressed as compounded once a year. So the formula is quoted rate divided by M, this whole plus 1, answer raised to power M, which is frequency of compounding, minus 1. So in previous example, our quoted rate was say 16% or 0.16 divided by M, which was 2, this whole plus 1 raised to power 2 M minus 1. This would give us something 16, there would be a point, right? 6, 4. Or we can say, if in terms of percentages, it would be 16.4%, 16.64%. So this is the effective annual rate. So whether we get 16% semi-annually or we get 16.64% annually, they both are same. So we have converted this rate of semi-annual compounding into a rate when there is an annual compounding. So they are comparable. So we have made it into an annual rate. So going back to our example, remember we need to find what is the effective annual yield on this bond. So the effective annual yield on this bond is 16.64%.